Let's have a look at this circuit now. I always start constructing circuits with lots of wires like these from the component that the wires tend to aggregate to. So in this case, it's the shift register, the chip right here. So I plug the chip into one of the breadboards. Now I move on to, before I connect any wires, move on to plugging in the rest of the components onto the breadboards. So I've got approximately 220 ohm resistors protecting the LEDs. I just plug one of the leg of the LED, the positive leg, directly onto the positive rail, so that saves me a few jumper wires. I've also got, you can barely see it here, I've got a capacitor here just to smooth out the current drawn by the LEDs as they are randomly turning on and off. I think this is a 220 millifarad capacitor. You can choose a capacitor about that size or a little bit larger even. It wouldn't hurt. Then I proceed to connecting all the wires, the jumper wires. So I start with the first data output, which is this pin right here. So if we have a look at the data sheet for this particular chip, you see that the zeroth data pin is number 15, which is this pin here. Just notice that with integrated circuits, pin number 1 is always on the left side of the edge that has that little dip in its package, or the very top, the short corner of the package. So this is number 1, 2, 3, 4, 5, 6, 7, 8, and switching to the other side, 9, 10, all the way to 16. So I'm looking for pin 15 and connecting that to whichever LED I'd like it to correspond to data output 0. Then, as per the schematic on the data sheet, data output number 1 is on pin number 1. So this one here. So take a wire, connect output 1, which is on pin number 1 of the shift register, connect that to the LED that I'd like to correspond to that pin, and so on. So this side of the shift register are all the data pins plus the 0th on the other side. Then I'm going to connect the shift register to the Arduino. So I'm going to start with pin 11 on the chip, which is the blue wire here. It's pin 11, and that goes to pin 12 on the Arduino, and that conveys the clock signal. Then we've got pin 12, which is the orange jumper wire. It goes to pin 8 on the Arduino, and it conveys the latch signal. And then finally we've got 14 on the shift register, the yellow wire, which goes to Arduino pin 11, and that transmits the data signal. I've also got a couple of other things. So I've got this pin here. This is pin 10, which is always on high, so logical high, 5 volts. I've got what else? I've got pin 13, which is always grounded. I'm not going to use those. Connected power, 5 volts. That's VCC, pin 16. That goes to power. And then I've got pin 8, which provides ground. There's also pin 9, which in this demo is not used. We'll be using this pin number 9 in the next demo 2. This provides access to the overflow bit, which we're passing on to a daisy chained shift register in demo 2. So you can already see what's happening when the sketch for demo number 1 is loaded. You just have the LEDs blinking randomly. So now let's have a look at the sketch to see how that is achieved. So here's our sketch. We start by setting pin configuration. So latch is going to be 8, clock is 12, and data 11. In the setup mode, we set up these 3 pins to be outputs. Set the serial monitor so we can have a look at the random numbers that we are generating later on in the loop. And then finally, we are initializing the pseudo random number generator. So I am sampling whatever value happens to be present in analog port 0, because I haven't got anything connected to analog port 0. That value is completely random, so it makes up a good seed for the pseudo-random number generator. So I'll look inside the loop. So the first thing to do is to create a random number from 0 to 255. So that's going to end up with a number that can be represented in 8 bits. So I'm storing that in this byte variable. Then I'm passing that variable to the write LEDs function, which will take care of passing it into the shift register and displaying the LEDs, displaying that number, that binary number on the LEDs. I wait for 100 milliseconds and do the whole thing all over again. Now inside write LEDs is where the writing in the shift register happens. The first thing to do is to turn or to bring the latch to low, and by doing that we're actually freezing the output of the shift register. The reason we're doing this for is that we want to freeze the outputs of the shift register so that as we are shifting new values in, the outputs don't change. We're going to keep the latch pin to low until we have completed shifting all new values into the register, and then, as you can see down here, we're going to revert back to high, so that will release the new values that we just stored in the shift register. The shifting itself happens here. So Arduino comes with a nice function for that. It's called shift out. We pass the data pin number, clock pin, and the pattern that we'd like to transmit, which is whatever was created by or generated by the pseudo-random number generator. This is just a constant that tells the shift out function whether we'd like to start with the most significant bit, so MSB is the most significant bit first, or with the least significant bit first, LSB first. So it's just which way you would like to load the byte into the shift register, which is what this constant is controlling. So upload it. Make sure it works. Okay, and we're done. So LEDs are blinking widely, and the circuit with the 8 LEDs controlled by a single data pin works.